Since the dawn of humanity, we have looked to the stars, captivated by the boundless mysteries of the universe. Our ancestors gazed up at the night sky and wondered what lay beyond. The journey that began with early astronomy and the launch of the first satellites has led us to the edge of a new frontier, the colonization of space. Today, the question is not whether humanity will venture beyond our world, but where we will go next. Mars has been long considered our most viable candidate, a planet of promise, a red world beckoning us forward. But what if Mars isn't the best place for us? What if the answer lies on a cold, distant moon of Saturn, a place that, in many ways, may be more suited to human life than the barren plains of Mars? Welcome to Titan. For decades, Mars has been the focus of our space exploration dreams. It's the closest of our neighboring planets, and early studies show that it was once warm, wet, and potentially capable of supporting life. Mars' proximity and familiar Earth-like features make it an appealing choice for colonization. But the more we learn, the more we realize just how difficult it would be to live there. Mars is a place of extremes. Its atmosphere is only 1% as thick as Earth's, and composed almost entirely of carbon dioxide, meaning humans would have to carry oxygen or build elaborate life support systems. The temperature on the surface averages around -80 degrees Fahrenheit, with drastic variations that could dip to more than -195 degrees at the poles. The thin atmosphere offers no protection from harmful cosmic rays, and the lack of a magnetic field allows radiation to bombard the planet's surface, increasing the risk of cancer and other health issues for any would-be settlers. Building a sustainable habitat on Mars would require extensive infrastructure, enormous domed cities to protect against radiation, massive systems to regulate temperature, and a constant flow of supplies from Earth to keep the colony alive. Producing oxygen, food, and water would be monumental challenges. The Martian soil is full of toxic chemicals, and even the water present on Mars is frozen in the ice at the poles. Any efforts to create a self-sustaining colony would be expensive, risky, and far from guaranteed. But now, imagine a different world, one that's not as close, but offers far more potential for long-term survival. Titan, Saturn's largest moon, is a place so alien and distant, it almost seems impossible that it could become humanity's new home. Yet, Titan's thick, nitrogen-rich atmosphere, abundant resources, and unique characteristics may hold the keys to colonization in ways Mars cannot. First, consider Titan's atmosphere. Unlike Mars, which is thin and unforgiving, Titan's atmosphere is thick and protective, with a pressure approximately 1.5 times that of Earth's. It's composed mainly of nitrogen, with methane and small amounts of hydrogen and other gases. This thick atmosphere provides crucial shielding from the sun's harmful radiation, much like Earth's own atmosphere does. Titan's magnetic field and dense air protect it from the cosmic rays that would bombard any Mars colony, providing settlers with natural radiation protection and keeping their health risks low. The thick atmosphere of Titan also opens up new possibilities for flight. On Mars, the thin air would make flying impossible. But on Titan, the higher atmospheric pressure and the lower gravity would allow for larger flying vehicles, such as drones, airships, or even human-piloted aircraft, to soar through the sky. Imagine exploring Titan's alien landscape from the air, traversing vast seas of methane and ethane. This would allow scientists and settlers to easily scout new locations, transport resources, and even set up mining operations with ease, something that Mars simply cannot offer. The lower gravity on Titan, only 14% that of Earth, means that building large habitats could be far easier than on Mars. The structures could be much larger, lighter, and potentially even floating, suspended in the thick atmosphere. These colonies could be designed to be pressurized environments, with the methane atmosphere outside providing a natural buffer against extreme cold. With the ability to harness local resources, such as methane, Titan could support a colony without the need for constant resupply missions from Earth. It's a world that could sustain life using what it already has. Consider the methane and ethane lakes that cover Titan's surface, liquid hydrocarbons stable at such low temperatures. While on Earth, methane is often seen as a harmful greenhouse gas. On Titan, it is a potential resource. The hydrocarbons could be harvested, processed, and turned into fuel for spacecraft, power for settlements, or even used for synthetic food production. The colonists could use local materials to generate energy, supporting everything from heat and electricity to water production and air generation. In essence, Titan could become a self-sustaining world, one that doesn't rely on Earth to survive. One of the most fascinating aspects of Titan is its frozen water reservoirs. Beneath its icy crust lies an ocean of liquid water. With advanced technology, settlers could access these vast underground water reserves, providing a continuous supply for agriculture, hydration, and industrial use. On Mars, water must be extracted from the soil or imported from Earth, an expensive and difficult task. On Titan, however, water would be accessible, abundant, and renewable. This could support everything from agriculture to advanced manufacturing. On Mars, growing crops is a constant challenge, with limited access to fresh water, fertile soil, and consistent temperatures. Titan, however, offers a natural advantage for agricultural production. Using water extracted from Titan's subsurface oceans and employing advanced hydroponic systems, a Titan colony could grow food in controlled biodomes. These systems could be powered by Titan's abundant methane, with greenhouses supporting plant growth despite the freezing cold of the surface. Titan could support sustainable food production for its settlers, allowing the colony to grow its own food and reduce reliance on imports. Titan's location in the outer solar system, orbital hub of Saturn, offers a unique advantage: access to the rest of the solar system. Once humanity establishes a presence on Titan, it could become a base for deeper space exploration. The resources available on Titan, such as methane for fuel, could be used to refuel spacecraft, sending them on missions to Jupiter's moons, or even farther into the outer reaches of the solar system. Titan could become humanity's first interplanetary spaceport, preparing expeditions to distant worlds and perhaps even interstellar travel. Titan offers more than just a place to survive. It offers a world of possibility. The resources, the atmosphere, and the opportunities for self-sufficiency are unmatched by Mars. With Titan, humanity could thrive, using local resources to power homes, grow food, and fuel spacecraft. Titan represents the future of space colonization, a sustainable, independent world from which humanity can branch out to the stars. The promise of Mars may be alluring, but Titan offers a deeper, richer future, one where humanity's reach extends not just to our nearest neighbor, but to the farthest reaches of the cosmos. Titan is the key to a thriving, sustainable human presence in space, an invitation to explore, to grow, and to reach beyond the confines of Earth. Will we take that first step? Will we answer the call of Titan?